A special episode of Just Enough Physics. We're still in kinematics, and I shouldn't do this for you, but I want to do it. So this is the answer to the homework question from the previous video. I'm going to go over it, but seriously, if you don't do this yourself, or at least try, if you try and spend a lot of time, you spend an hour playing with this and you get stuck, and then you watch this video, that's going to be useful. If you just say, he's going to do the video, I'm just going to watch the video, whatever, then it's not going to be great. Okay, but I want to do it because I love to do this, so I'm going to answer these two questions. Number one, what if the acceleration was negative 0.01 meters per second squared after 1.5 seconds? And then number two, if the acceleration is negative 0.02, how long would it take to stop? Okay, so let's go back to our code, and I've copied it so I won't mess it up. And let me just put over here as a comment, one, what if a equals negative 0.01 meters per second squared? 2, how long to stop if a equals negative 0.02 meters per second squared? Okay, so I think the number one question, and we could do this analytically, but I'm just going to skip over that part. I probably should, but I'm just so excited right now. So let's just go up here and just change this to negative 0.01. That's all I'm going to do. And then I'm going to run it. There you go. So what we should notice here is that it did not go as far, right? Because now, instead of speeding up, it's slowing down. It has an acceleration in the negative x direction, so it's going to be slowing down. I'm using my hands right now, and you can't even see that. I don't know why I'm using my hands. I don't know what to do with my hands, but so it's moving and slowing down. So we would expect it would be much shorter than what was a 0.97 meters when it had a positive acceleration. Let's just do this too. Print v equals v meters per second. So what's the velocity at the end of this? And this is 1.5 seconds. Okay, so you see it's about half as, no, it's not even half as fast because it was 0.45 to start with. So let's slow it down just a little bit. Okay, so that one's pretty easy. All we have to do is change acceleration. Okay, but now what if I do this? And I want to know, how long does it take to stop? And where does it go? Let's just run it. So you'll notice here that it is not stopped after 1.5 seconds. What if I said, okay, well, what if I do it a little bit longer? 2.5. It's even slower. Okay, so let's do 15. Let's just do 15. 15 seconds. Let's do 10. 10 seconds. Let's go even longer. It still has not stopped. See, because this is still a positive velocity. So let's just go big. 20. It still hasn't stopped. It's pretty close. Let's try 23. I'm just picking stuff. I can't even remember the right answer. Okay, right there. Look at that. So at 23 seconds, it's actually going backwards. So we need a little bit shorter. So 22.5 seconds. Okay, look at that. You have something that's negative 2 micrometers per second. Okay, so that's essentially stopped. So I'm pretty happy with that. So it has stopped. And it has gone this far. But how long did it take? Well, I got that right there, 22.5. So it took 22.5 seconds to stop, and it went 5.06248 meters. And that's the answer. And now you say, oh, well, that's kind of weird. You just kind of fudged the numbers and reran it a whole bunch of time to get it. Yeah, that's what you do, okay? You get the answer. That is a completely legitimate way to do this. Okay, but maybe you don't like that. You're like, that's not cool. I want to do it the cool way. Okay, well, what about this? While v is greater than 0. And then let's print out the time too. Check that out. Time, 22.5 seconds. Final velocity, 0. That's 0. Distance, same. Okay, so here's the thing. I had that loop. We put the loop as a time loop all the time because that makes sense. But it doesn't have to be. Okay, I could do it as long as the velocity is greater than 0, which is what I did. As soon as the velocity becomes 0 or negative, boom, it stops. Okay, so there you go. Oh, and I see here I do have a pretty small time step. Okay, let's make that more realistic. Okay, that's better. But still, same answer. Okay, there you go. That's the solution to that problem. So again, do these problems. You can't just rely on, just whatever and just, watch me do it and figure it out. You got to do it yourself. You got to play with the code, change the code. You cannot break this. Let me just show you something up here. Say I'm and I'm not even going to give you the link to this code, but let's say I messed it up so bad I can't remember what I did. If I go up here and I go to reset, are you sure? Yes, I'm sure. And then it goes back to the way it was. Actually, I didn't save it, so. But if he had saved it, that's what would happen. It'd go back the way it was the last save. So you can't break it. Okay, don't worry about that. And again, if you're into this stuff, I'm trying to work through the whole introductory physics course with just enough things to cover the main things that you need to know. You can like this channel. You can give it that bell thing so you know when I post new ones. I'm trying to post these every night. If you want to support this page, there's a Patreon link down. And I'm going to make another video soon. Later.